Uh, I hope now I'm audible. So we'll start with our session now as we have 63 connected. Uh, so before starting this session, I will like to highlight some points how we are going to pass on this session. So there are some key points which we have to first figure out. So after every 10 minutes of teaching, I will provide you a 10 minutes break to ask me questions. So the question round will be you can comment whatever question uh, you want in the comment section. I'll answer them. So I'll not be testing anything on the chat box. I'll answer them verbally, and I hope I am clearly visible to you all. Secondly, at the end of this session, we'll begin with our notebook workshop. Like we'll actually code everything. So during coding, if anyone wants to try it simultaneously, they can try it on their own also. I have shared my GitHub link on WhatsApp group, so you can check uh, and communicate with me if needed. So uh, we have two supporters joining this group. They will be also helping you solving your doubts. So this was the guideline of the tutorial today. So let's start with the session, and I hope I am clearly audible now. Like many of them are still commenting, it is not audible. Okay, so I'll start with the session. So introduction to machine learning. Why we have why in IEEE or why we have started this course. So currently industry is growing in a direction where everything needs machine learning. Like it from Google, they need machine learning, where robotics application, maybe COE in our college, Center of Excellence, they majorly works on machine learning. So why we are starting this with the first year students much more earlier is that we should get introduced to this subject as fast as we can, as earlier as we can. So this is our motto in IEEE, to provide you the perfect guidance and approach towards machine learning and any other technology which is related to electronics or system related to electronics. So I'll start with this session now. So many of you have attended my previous session on IoT, which was conducted in college, which was known as Pratham. So you know my approach towards technology. I always quote this, that every innovation or every technology development in engineering is somehow been inspired by nature. Like we always want to be like nature. Like we always want to be one who can explore the nature in the best way it can. Rather, at the same time, it should be the efficient way. Like we don't want to do hard work. We want a simpler way towards the innovation. So this is also a story. I'll try to explain machine learning in form of a story, so it will be more relatable. So I'll start with a story. How this machine learning came into existence. So as we all know, human is the uh, most intelligent element on the on the planet. So the intelligence come with the stream that we don't want to work. We want a system which works for us. Like we just need to command them and they will perform our task. So for this, before 1950, various systems were designed. Like we were able to make a robot which can perform a task to a given command, and we get the output. But this was not the end. Many researchers started to think, how about we'll start building a system which will predict what I'm going to command him, or which will predict what I want and work accordingly. So this is something which was During that time it was told like this is just ridiculous, this cannot happen, how can a machine interpret what you want or what output you are expecting, because till that time people were more into things like whatever we provide should be the output, and that was the era of technology at that time. So uh, what people think machine learning is. So a normal coding approach, by this slide what I mean is, when we provide a data or a program, we get an output. Suppose I program a task to predict my age, or let's say I want to display my age on my website. What I'll do, I'll provide data of various ages corresponding to that age, what the person height is or something related to the height, and the data accordingly, if this will apply if else loop, and will say, yeah, this is my data, this is my program, and I want this output to be originated. But this is not the case with machine learning approach. So I'll explain you this with an example. So we know that how a baby start recognizing any object, or let's say object, or we can say a fruit. What a baby do to recognize thing. As I have told this, every innovation in field of engineering is somehow inspired by Mother Nature. So people started seeing nature to solve this problem, and the most intelligent animal on the earth is human. So machine learning is somewhat related to designing an artificial human brain with the help of mathematical computations. So this is the basic approach of what machine learning is. So I'll start actually what it contains in form of cells. So before going on that slide, this is what I had discussed. Artificial intelligence is nothing but designing a human brain in an artificial manner. So the heroes of artificial intelligence or machine learning are these two gentlemen, Franklin Roosevelt and Geoffrey Hilton. So the story starts in this manner. In 1960 or 1970, when the robots were being very common, and to build computers was started, to build a smart computer, or the need of computer was increasing day by day. So Hinton felt the need to have a system which can work artificially and which is more intelligent than the previous systems. And to be precise, it should behave like a human brain, like how human predicts or work on a system and predict the questions, like predict what is going to happen or what task to be taken in an intelligent way. So all the bigger innovation faces various hard routes. They get rejected, they get people abandon them, everything happens, this cannot be done. So all of this, Hinton started to work on a system, uh, started to study human brain, how a human brain works, and he met Frank Roosevelt, who is a psychologist or a psychiatrist, who majorly was working on a human brain, how human brain functions. So Frank got very attracted and very impressed with the idea Hinton was having to have a computer with intelligence or smart sense like human does. And he told Hinton like, I'll support you with my all of my knowledge how a brain works. So they started working together, and they found out human brain majorly works on based on neuron systems. What I mean by neuron system is human brain contains a structure of neurons. By neuron, what I mean are they are set of cells which are connected in a dense manner, and this neuron are responsible for each and every decision taken by human. Suppose you want to pick something. So this neuron will alert the your action, like your brain is divided into sections. One is to control your physical actions, and control emotional similarly. So when you think I need to pick up something, so this neuron gets triggered and an action is taken, like signal is sent to the organs which actually takes part in the action, like hands or leg you need to move. This is done by the neurons triggering. He figured out, the Franklin and Hinton team figured out this, and they started to build a system which can mimic this, but in a mathematical way. Like we need to, what is our motto? We need to replicate human brain with an artificial brain. So they started to build a system called as perceptron. So what is a perceptron? It is nothing. It is a replicate of a neuron. So as you can see, this is this is a neuron drawing. As you can see, this is a human neuron which has been sketched. So what the team, like the Roosevelt and the Frank team, studied that each neuron has some input points. Like neuron gets some inputs through this dendrix. This is the dendrix. Just I'm sorry for my handwriting, but this is the best I can do. So this is the dendrix. So any signal, if say I want to pick up something, it will, this signal will be converted into electrical signal, and it will be passed through dendrix to this uh, neuron. So these are the dendrix. So from here we get the input signal in human brains, and this is then passed on to the cell body. So this is called cell body, where this the information is processed. So how does this information is processed? So this is the major field of research currently. Many people are doing research on this, how this actually is done, but we are not able to figure out how it works inside the brain. But we have find some solution so that we can mimic this thing. So as I always say, like in my previous session also, engineering solutions are never perfect. We just try to replicate them in a manner that we can accept, like we can do. For example, we cannot fly like a bird, like by spreading the wings, or uh, like the bird fly, or we cannot land as proper as bird, but we can replicate it. Like our helicopters can land anywhere, but it is somehow related to the bird. Like we cannot get the 100% functions like the system behaves in nature, but we try to replicate it. So similarly, this is a model. Like this is our case. Like we need to replicate this case in our mathematical form to design an artificial brain. So this is the cell body in which they process the input signal which we get. We process them and we send the signal through this axon. This is known as axon bay. Like from here the signal gets transferred, uh, and it is then sent to the next neuron connected. So how it is sent to the next neuron? So here is a synapse gap. Like if we consider like this, the other neuron is connected. Here we have other neuron. So in this way, other neurons connected. So the gap between the end of the dendrite and the start of the next neuron is called as synapse gap. So from this gap, a chemical is released, which is uh, which is responsible for transfer of information from one neuron to other neuron. So this was the basic how a cell neuron, or how a cell neuron in a brain works, and the data is transferred. Similarly, we designed our artificial neuron. This is our artificial neuron mathematical representation. Before coming to this, I will understand this how it is done, but with an example. Suppose we'll relate this to two things. Like we'll relate the actual neuron scheme of cell and our perceptron. So in our neuron, the brain neuron, we have dendrites to get the input signal. So to replicate this, we have created this thing. So this section you see is the layer, flattened layer. It is called a flattened layer, where we give the inputs, whatever inputs we need to give, or whatever the data we need to process, we give through this flattened layer. And then when we see the cell body, there is a neuron body, there is cell, which is known as nucleus, so which is responsible for processing the information. So in this case, in our artificial neuron, we also has this cell body. So this block is the cell body. So what is contained? So it may majorly merge all the inputs, and it is passed through a function which is known as activation function, through which we get the output. So we'll understand each and every parameter which has been described in here, like the w, what is the w, what are the x, or what this function means, or what is the activation function. But I just want to introduce you how a basic system works. So I presented this. So I hope a perceptron is clear for you. And if you have any doubts regarding this, please ask me in the comment section. That I'll be having 2 minutes break current now. Please ask me the question if you have any. वेदांत चेक करो तो बराबर चल रहा है. क्या है? कौन सा स्लाइड है अभी तक? कौन सा स्लाइड चल रहा है? ये इंट्रोडक्शन नहीं, थोड़ा सा 15 सेकंड पीछे जा गया. कौन सा है देखना एक बार. मेरा परसेप्ट नहीं, कुछ एरर दे रहा है क्या? Okay, so I got a question from Dhairya Shah. Can you repeat the activation function? Yeah, I'll repeat it. We'll go in detail with every part. Currently, what I'm saying is, are you able to build a knowledge, like build a background how machine learning is? If yes, please comment down below. Question there. Second line. And please feel free to comment below, like this is not going to be shared anywhere. So just be free to ask me questions. So I'm not able to interact with you guys like I did in my IoT session, like it was a live session, but I'm trying my level best to answer your all questions and make this presentation as effective as it can. So please, if possible, just interact. So I got another question from Sheikh Mohammed. Perceptron is just an internal function now, like we don't have to work with it while we work with ML. Yeah, it is an internal function. So perceptron is nothing but how you define one neuron. Like we know that a brain has many neuron connections. So we'll see what the perceptron actually is. You just need to understand how it works, and it is an internal function in the ML workshop. Like when you code it, it is not important to describe each and every perceptron. It automatically get generated. So I'm just making you familiar with the situation, like how a neuron in human brain and works, and how it is replicate with a mathematical point of view. Am I clear? So, and if you want me to communicate in any other language, you can tell me that it is completely cool. So I can speak in Marathi or Hindi also. If you need, I should explain in some points in Marathi or Hindi. You can tell me, and just feel free to ask me in that way also. So as I'm not getting any doubts currently, so I'll move forward with our further slides. So in our previous session, we saw how a human brain is constructed and how it has been related to machine learning, like how we consider human brain and artificial neuron, which is called as perceptron. So I'll come back to the previous slide. So we'll start with things how a machine learning works. Okay, so I have a question. How does a baby learns to walk, or how a baby learns to recognize a food or say fruit and anything? I'm starting with a baby, like a small baby, how it start to recognize things. So when I was small, what my mom used to do is I used to be provided with a data. Let's say I what I mean by data is, let's say data is fruit which I have been provided with. Okay. So my mom used to give me some fruits, say apple. I was given an apple, and when I have the apple, what a baby do is he start figuring out how it looks like. It is circular. Baby don't know that what is circular in shape, but it start to feel the things like it is very hard, or it is time of circular, or it has a color which is red, which it recognize later. But it start recognizing things like it start to capture the parameters of that fruit, like what parameter fruit has. So parameters like fruit has color, shape, maybe its weight, its taste, obviously. So these are various parameter on which a baby start recognizing. But what is the main point how a baby recognize a food? When my mom should teach me like anything, what she should do, I'll give an example. When I pick a apple, say apple, I don't know what is it. I know it is something I picked it, and then my mummy used to label it like this is an apple, and you will be eating an apple. So what my brain get, I got a data, like food was my data, its various parameter was my data, and my mom provided me the output, what was expected. So the output was the label. Like my mom told me it is an apple and it is a fruit. So I get, acha, this is an apple and it is a fruit. I got my data labeled. Similarly, with other fruits, say chiku, like my mom used to give me chiku, and I'll recognize the parameters, and then my mom used to label it. So my mom will say this is a chiku, the fruit name is a chiku, and it is a fruit. So in this manner, babies start recognizing things, like we provide them data, and we on our own provide them label, like what is the output of this. So this is the first way of machine learning. Like there's various ways machine learns. So this is the first way, which is known as, like, I should erase these things. So just a second. So my mom provided me data. So I was provided by data like apple, say apple. I recognize its various parameters like its shape, its size, its color. Now my mom provided me the output of that particular data, like we say label. So what my brain started to store, like how an apple looks. So apple has some shape, say circular. It has color which is red, and it has been labeled as apple by my mom. So this type of learning, which needs a supervision, uh, here my mom supervised my learning. So this type of learning is called supervised learning. So our first type I will write somewhere in here in the corner, learning type. So supervised learning, where in this type of learning the machine is provided with data, uh, pre-trained data, and provided with the outputs, like with the label data. This type of learning is called as supervised learning. There are various type of other learnings like unsupervised learning or reinforcement learning. So I'll majorly focus on supervised learning in this session. We'll be discussing unsupervised learning and reinforcement learning in our future sessions. But to be precise, we'll start with one thing and will be expert in that thing, and we'll move to the further. So I hope supervised learning is clear till now to all of you. So if yes, please comment down, and if you have any doubts, you can ask me. So I'm not getting any doubts. Please comment something so I'll understand if people are understanding or not. So Rakesh is saying yes. So you understand what the theory is. So Shoaib is saying not getting. So what you're not getting, like uh, the supervised learning or the overall session, like what you're not recognizing. Okay, so I'll explain once again what is supervised learning and what actually learning is with some different examples. Say uh, okay, so let me think for an example. Suppose you're building a system which should recognize certain things, like if you provide them a photo of an apple or an orange, it should recognize this is a fruit and it is an apple. So to design such system, this was the primary task what AI researchers have taken in 1950. What I discussed before, the Frank and Hilton was working on this systems to recognize uh, fruits with the help of photos. What they did, they gave a lot of photos of different fruits like apple, peas, and they manually labeled it. So whenever a photo is put under a camera, they took a its snap and they labeled it. This is an apple. So writing an letter like apple is not a computer can interpret. What a computer interprets language of 1010. So one was denoted to apple, two was denoted to orange. When an apple photo was given, the label was given as one, so they recognize, okay, this is an apple. If we get a label one, which means an apple. In this way, Roosevelt and Franklin designed their model. So to explain this, I have given an example of how a baby recognizes things. So how a baby start recognizing things. So first of all, a data is given to a baby, like a baby picks an apple, that work as a data to them. So the data is given, and then the mom provides the label, like mom tells the baby that this is an apple and it is a fruit. So this all information gets stored in the brain, uh, baby's brain, and at any time, like the baby grows, and when we ask him what is this, he'll say apple. So this type of learning where mom plays a role of supervisor to the learning machine, which is a baby in our case, is called a supervised learning. So I hope I am clear out. So I'm getting another question. So just a second. So yeah. So first I will answer Said Hazmi's question. So the question is, how does the unsupervised learning works then? So what happens in unsupervised learning where we don't provide them label data. Here we are providing them label data. By label data, what I mean, the supervised data. Like for every data, we have a supervised output. Like for here, in case there was mom, but interpret this thing that in unsupervised learning we don't have mom. We have to start learning on our own. So how do we do this? So we start categorizing things. Categorizing this thing. What I mean by categorizing thing is we'll start to map their parameters. Say, so I'm going out of scope of this subject, but okay, I'll explain you. So let me find a blank place. So I'll explain here. Sorry for the congested space. So I'll plot various parameters of different object what I want to recognize in unsupervised learning. Suppose I am recognizing apple. So I'll plot its size on x-axis. So size, and its color, say not color, it's say color. Okay, so color on y-axis. So as we go on increasing the y-axis, the red current gets more darker. So apple has a lightish color. So a size of something, say 2 centimeters, or it is very big. So 2 centimeters. Let's consider. So I'll plot my data over here. So similarly, I'll plot apple's data somewhere here, and at the same time, I'll plot various data of fruits also. See, I'll plot chiku data. It will be plotted somewhere here. So whenever this data is been categorized in this manner, so we can have a separation between them by this line. So whenever a fruit is been selected, say I'll select apple, and it has size of say 3, and its color is on the range of 8, and it's somewhat like lies here, then we'll compare where to which cluster it is more closer. So it is, if it is closer to chiku, then it will be chiku, or it will be, if it is closer to the apple cluster, then it will be apple. In this way unsupervised learning works. So we don't provide them label data, but we provide them with the various parameters of data, and they on their own interpret the uh, separation between them. So I have answered the question for Syed. Syed's question, I have answered it. So the next question is, supervised learning is basically in which we know the output. Yeah. So in supervised learning, we always know the output for a specific data set, like for a specific period. We trained on we train our machine with that data which has its output map, and then we train that then we run that trained model for an unseen data. So this is the flow. Like we train the model on our known data and known label data and their outputs, and then we provide the data which output is not known, and we'll get the output of that data based on the learning what we have done through this uh, previous data sets. So I hope I've answered the second question, was which was asked by Jay. So the third question is that given by, so supplying data with parameters and label is supervised learning. Yes, supplying data with parameters and learning is supervised learning. So if I'm clear, should I go further now? If yes, please comment yes or something. So I'll move further. Okay, I'll go further now. So as we have seen how machine learns and what are different types of learning which can be used, like supervised learning, unsupervised learning. So we'll be majorly focusing on supervised learning in this session. So I'll go back to my story, the story of the inventors of uh, this new innovation of artificial intelligence. So when Hinkland and Frank was working on their model, what they were doing is they were used to supply various photos of, say, human. They were building a system which can recognize human being and like female and male. So they were feeding various photos of female and male, and they were labeling one for male and two for female, zero for female. So if a photo has a photo is of female, then the label will be zero. In this way, they have labeled a lot of photos and created a big data set. But when they started actually implementing this model, they found that it was not working properly. So why this was happening? So Franklin was in a search of solution for this question, and he found out, like, in human brain, as human brain develops and the capacity of brain to store data increases, its neural connections also increases. Like a adult like us has a very well defined neural connections in our brain. So to make our machine as intelligent as humans, to work with larger data sets or to work with larger information, we need to build a more complicated or more connected network. So this network was called as deep network. So as you can see, this is the network. So this single section is what called as perceptron. So you can say that this deep neural network is connection of various perceptrons and connecting them together, forming a cluster of networks, cluster of perceptron. This is a artificial what an artificial deep learning network looks, and this is the human brain, how the connections of neurons are present in human brains. This was the inspiration for Hinkland and Fragment research to improve the computation and the data analytic powers of machines. So, so this is the deep learning model. So as you can see, there are two more. This is called as layers. We are implementing layers of perceptrons, one after other. In this way, we can create a deep neural network. So you can see this layers are in sequence. Okay, we need to design them in a sequence. And the major question is how to select how much neurons should be there, should be present in a neural network. So the question to this cannot be predicted. Like, it needs a lot of research work done on single model. Like, if you are working with some models, and you have to work with them randomly predicting how many layers or how many perceptrons should be used to build a model which can compute your which can solve your problem. So to do this, you need a lot of year to actually practice this thing. But there are some tools which can make your work easier, which is out of the scope. Like, we will not be discussing that tools currently. Just understand this: the neural network should be designed in this manner, deep neural network, to solve the uh, more detailed problems. Okay. So I got a question from okay, so that is not a question. So it was an answer given by Nikita Devkar to. Okay. Yeah, right. There is third type of reinforcement learning which does not need data or nothing. It works on its own. But that type of learning is currently been it is in research, so I'm not be discussing it on in this session. Like, it is not sure how the system is going to work. It is currently been researched. So rather talking on the thing which is currently researched, it can change. So we should talk on the system which has currently been developed. So I have not touched the topic, so I have not discussed that topic. Sorry, if you wanted it, I can explain it. So I hope you understand how a deep neural network is, and if yes, if you had any question regarding deep neural network or deep machine learning problems, like deep, what is a layer, anything, you can ask me in comment section right now. I'll be taking 5 minutes break for your question and answer. Like, I'm seeing many people are leaving this session. So is there anything I need to improve or I'm not able to communicate? So please tell me so I can make this session more lively. So please comment okay if it is okay till now, or if you have any problem, just comment something so I'll understand if people are understanding or not. So I'm getting okay, proceed. Okay, so you're understanding till now. So we'll start with the things how machine learns. We have discussed everything. What are the various process involved in learning? How machine learning can work. We have discussed everything. What is deep neural network? What is a neural network? And how it is implemented. Who are the researchers for this? We have been clear with this. So we'll now start with how a machine learning system actually learns and predicts the output. So I'll come back to my previous example. I'll change my example. So how does a baby learns to walk? we have we all we all know how to walk, but when we are baby, our mom or dad used to hold our hands and make us walk through the corridor in the house, or we used to go in park where where my mom used to hold my hand and she used to help me learn how to walk. So how a baby start learning, like how baby start walking, is the question, like how it starts walking. So what I have observed with this case is when a baby starts walking, it will never take a smaller steps, like it will take a larger step. The baby can, like he'll stretch his leg a lot and then take the steps. So this is something which is called as forward propagation. Like baby is told to walk, like it has been given command like start walking, and it will start with something random values. Like suppose we'll say that the angle at which the leg of the baby should be to start to walk stably is theta. Like the baby will start walking by the maximum value of theta, like he'll stretch all his knee and then he start walking. So when this happens, we'll get an output, like baby will walk. The output is baby will start walking. That is an output. But the output what which we get, it is not the exact one. So the mom, who is the supervised learning parameter, like who is making the baby learn how to walk, he will correct the baby by telling her that no, you are doing this wrong and this is the error. Like you don't need to step a long foot, you just need to step a shorter foot and start walking. You need to take a smaller footstep to be able to walk stably. So what mom did was called as correction of error. Okay, by correction of error, what I mean is mom corrected the error the baby performed. Like what the baby performed was is test his full knees, and that was a wrong task. So the mom actually overcome the error and defines that this is an error, and you do not do this again. Like if you're walking, you start walking again, like you have started a new task, so you should not take this much big step, you should decrease this step. But mom never tells the baby that how much it should decrease. Okay, so baby understand this. Okay, I need to decrease my step. I made an error in my previous operation, and it will start slowly decrease. It will start decreasing. Baby will start decreasing the step slowly. So at a stage, he'll understand. Okay, I need to step this much to walk stably. So this was a very effective example of how a supervised learning works in and how it is done. So I hope the example is clear to you. In this example, now we'll start to understand this mathematically. So what the baby was doing, what task was assigned to the baby is what task assigned to the baby is, baby needs to walk, start walking. Okay, so task is start walking. Okay, supervise, who is supervising the task? So supervisor is mom. So now the as task begin, what the baby do? It takes the maximum value of angle bit. It takes the biggest footstep the baby can. So let's consider the angle between the foot. What the footstep is theta. So the theta is maximum for the first case. Like baby took the maximum value of theta. In order to make this learning successful or to make the baby walk properly, what we need to do is we need to decrease the theta. Like if it, in this case it is say 90 degrees, it is very much higher, say 45 degrees, sorry. So we just need to decrease the this value to say 5 degrees or say 10 degrees, so the baby will able to walk properly. So how the human brain do this? How does the human brain understand, like I need to change this parameter? So this is what we called as learning parameter. Like by changing this parameter theta in the case of babies walking, we can change the output. Like it will start walking properly. So this is called as learning parameter. So we understood this by what we understood by this example is human brain also in like in beginning of a task perform various errors, but human brain is capable enough to reduce the error and get the proper output. So if we want to build a system which is similar to the human brain, we need to build a system which is also capable of reducing its error and predict the perfect output. So in terms of neural network, this is called as forward propagation and backward propagation. What I mean by forward propagation is, so let's take, like again go to the example of baby. So uh, what was the first step of the operation? Like baby started walking, it performed some task and got an output. Okay, what output we got? The baby took a very large step which was more than expected. Okay, this was the first step. So and at the end of so I'll point out everything. So what was the first step? Baby took his baby started walking, taken a large step, large angle step, large step. So after doing this, the mom recognized it is wrong. Like mom is the supervisor over there. So the mom recognized this output was wrong. So what mom did, it computed the error between the boy's action, the baby's action, and expected action. So this complete step is what we called as forward propagation. So I'm getting some questions. So I'll wait for the backward progression. I'll answer the questions first. So the questions is, so how we make deep learning network mechanically. So mechanically, deep learning network, what do you mean? By connecting various outputs together. It is the answer. Like if you are getting an output from certain system, you connect it with the different system, and in the interconnected system works as mechanical system. After that, no, the question is the perceptron pass data to the other perceptron, or it stores the data also. No, perceptron only passes data from one perceptron to other perceptron. It never stores the data. Okay. Uh, in this is what I'm telling is of DNN, like direct neural network. But when talk about CNN, which is convolution neural network, which is out of the scope, it also saves data. But currently, keep this in mind, it will never store data. It will pass on the data to the next layer. Okay. After that, so can you give me a real life example where machine learning actually works? So first example is autonomous driving. All the autonomous driving currently been developed like by Tesla or various car manufacturers. They majorly use this machine learning. We'll see a full-time running model at end of this session. Currently, just focus on the concepts and theory which you need to understand. Am I clear with this? So I have one more question. What is the accuracy of such model? So accuracy majorly depends on various parameters. So we'll discuss in a later session. After understanding how a neural network actually works, we'll discuss is how to increase accuracy, or what accuracy the model can predict, or how can we predict accuracy. All this thing we'll discuss in further slides. So are there any questions? Other questions? If it is okay, then please comment something so I can move forward. So I have a question telling how a new layer is created. So Shahid, we never creates layer. We predefine the neurals, like hold the layers, the complete layer set has been predefined. Like if I want a neural network to be designed with four layers, then it is predefined. No, layers cannot be developed automatically. It is predefined. How we do this is by coding. Like we'll see how it has been done once we go in our coding session. Hope I'm clear. So if you are satisfied with your answer, please comment okay or yes something, so I'll understand and will go further. Okay, so I'll move forward. So we have discussed what is forward propagation. Forward propagation. I'll just repeat the things. So forward propagation is nothing but as you can see in this. First, we'll initialize the parameters. Like in case of babies walking, the parameter was theta, the angle between the two legs. It should will initialize the thing, like human brain initialized it with the maximum value in our example, but we'll initialize the uh, parameters in our model with some initial values. Okay, so here you can see weight. What is weight? So as a baby, as in case of baby, we were having a parameter theta. Okay, so this was a learning parameter as explained. So similarly in our artificial model, weights are the learning parameters. So we can tune them, we can change them in order to get the desired output. We'll understand what is weight and activation function after this slide in detail. I'll explain each and every part of weights and activation function after this slide. Okay, so this is the first part in forward propagation. We'll initialize the learning parameter with some random values. Then we'll put this system through our neural network, like from our with our through our perceptron or deep network which we have. And then we'll calculate error. So there how we calculate error. So suppose a predicted so we are majorly working with supervised learning, so we have the output. So say the desired output is y, and our predicted output or obtained output, say y cap is, it is uh, it is the obtained output or obtained output. So the difference between these two, like y minus y naught, is the error. Okay, So in forward propagation, we'll come till the error, like will we generate the what is the error and we'll store it. Now what happens in backward propagation? So let's get back to the example, like baby's walking. So once mom understood that baby is taking a wrong step, like the foot is his the angle at which he's stepping is not correct. What he did, he uh, he uh, he told the child, like, you need to decrease your foot angle, like you should step smaller footstep, you should go with a smaller footstep. So this was this is called as error correction. Like mom requested the machine, like in our case machine is a child, to manipulate the learning parameter. In case of babies walking, it is theta, to decrease the theta in order to reduce the error. Okay, so this is the backward propagation. So we got the error. We'll go all the way back and update the weights. For by weight of what I mean is, in our case theta, like the angle the baby's stepping, suppose it is theta, then to decrease the theta we'll go all the way back and update it, and again come back to the with the forward propagation and check the error. In this way a machine learns. It will predict an output, it will check the error with the desired output, and if there is error it will go back to the initial state and update the parameter, updating learning parameters, and again get the output. And this is continued till we get minimum error. So this whole thing is called as forward and backward propagation, or this is the neural network working principle. So hope I'm clear with the how a neural network works. If yes, please comment down in the comment section. If you have any question regarding this, how a machine is learned in forward or backward progression, I'll answer them. Uh, so I got a question by Sayed Hashmi. So in the normal case, who is the supervisor? So in the normal case, we provide the data with a communicated label. So in normal case, we are the supervisor for the machine. So as we are providing them the label for their data, so we are the supervisor for the machine. Hope I am clear with this doubt. If okay, then please comment okay. So the question by Amay is what actually happened with the submission and activation function block. So I'll start with it. So okay. So how our neural network looks is, I'm drawing a single perceptron. So this is how our neural networks look. So from here we get the inputs. Say in our case, inputs are x1 and x2. Okay. So what actually happens here is uh, we also provide some weights. So as I explained, what are the weights and what is the weight, why we introduce weight. So the weight are majorly introduced as a learning parameter. So as we cannot change the input data's value to get a desired output, what we change is the values of weight. Suppose our output from this neural network is to be 10. We want a 10, like output to be 10, and our input are 5 comma 1. So in order to get the output equals to 10, what we need to do is, so the summation will be x1 into w1 plus x2 into w2. This will be the summation from here on. So this value should be equal to 10, or should be near to the 10 is our objective. Should be near to 10 is our objective. So in order to do this, what will what we'll be doing, consider x1 as 5 and x2 as say 1. So our input x1 is 5 and x2 is 1. So what our system will look like, so 5 into w1 plus 1 into w2 should be equal to 10. Okay, so now if I'll tune this w1 to say we'll say something like 1, say I'll tune it to 1, w1 equals to 1 and w2 equals to say 5. So what my system will look like is something like this. So 5 into 1 plus 1 into 5, it will equals to 10. So our major role to learn the machine learning is to get these parameters 5 and 1 as they are the ideal parameters. By giving this we'll get the desired output. To do this, we'll first initialize our weight with some random value. Say in this case I'll initialize my weight with say uh, 0.1, zero point 0.2, and as we go on forward and backward propagation steps, this weights gets continuously updated, and we get closer to the desired weight values, which are 5 and 1. So in this way a model runs. So I'll further explain what actually happens uh, inside this activation function and bias function, why we have used activation functions. So replicating the neural model, like how a brain works. Our brain has various neurons I have discussed before. So this neuron gets triggered whenever a specific amount of data is achieved and it has been transferred to the next neuron. Like how a neuron will understand I need to pass on data now. Like I have got the data and then pass on to the other neuron. So this is done by activation function. Like there are various type of activation functions. We'll see them in detail. Like so these are the various type of activation functions: sigmoidal, tanh, relu, Rayleigh relu, max out, elu. These are nothing but they provide you an output in form of 0 or 1. Like if I have an activation function, say sigmoid activation function, and I have input data say 4. So when I pass it through this activation function, which is 1 upon 1 plus e raised to minus 4, I'll get some output. And we can use a if loop here. If we get output greater than say some specific threshold value, then our neuron will get triggered. Similar to what the brain do, uh, we have replicated this thing by using an activation function. There are various activation functions here. You can study them in detail. Like I'm not going to cover the mathematical part currently, but I hope you got what the activation function do and what are bias weights and bias are used for. If you have question regarding weights and bias or activation function, you can comment down below. Please comment down if it is okay or you have any question regarding activation function or weights and biases. Yes, the weights are just some multipliers on which our output is dependent. Uh, the case of bias, I'll explain how a bias is worked practically while we are coding. So machine learning is something which we will learn when we actually start coding. Like I'm explaining just stuff how a machine learning works. So weight and bias will be more clear when we start coding. So bias is nothing but weight at the initial stage. Like in case if your output is say bias is something. Let me consider an example to explain this. So I will be writing on the left side corner in this box what bias do. So bias is nothing but if your system is working on a data set which is not linearly distributed, like what a linear distributed data set is something like this. Okay, it has its input and an output linearly divided like this. But if your data is not linearly divided, it is something like this. Say something like this. So this area it is called as bias area, and we need to overcome this, or we need to make it like a linear area. So what we do is we add that particular value to our activation function or to our perceptron value. So it will look like summation x1 y1 plus x2 w2 plus b. So b is your bias area. So bias area is nothing but this area. I hope I'm I hope I'm clear now with the bias. So what are the uses of different activation functions? Okay, I'll explain you with an example why an activation function is an important function. So suppose you are building a model. Suppose you are building a autonomous driving car system. How a autonomous driving car actually works? So it has a camera on it. So what does camera do? It's continuously take pictures of your surrounding area, and this picture has been processed by your computer. Suppose your picture has taken a car in front, and there is some sign, there is signal light at the right which is green. So there are multiple objects in your image which need to be worked on at the same time. Okay, so so how will you predict key what is more important, like to see a car in front of you or a signal light? If you not brake your if you are not if you not apply brake at right time, like there will be an accident with the car standing right in front of you. So to predict probability which function is more important, we use this type of activation functions. Activation function just give you probability of that situation. Suppose I'll give you one more example. Suppose you are building a system to recognize four fruits, apple, any four fruits. So what an activation function will do, when you when you provide an input specific to certain fruit, say apple, you provided an parameters regarding apple. So what color apple is? So it is red color. So one parameter is red. So you have provided red color and its size, which is completely matching with apple and not matching with the other one. So this activation function will help you to predict the probability of what it is actually. that it is an apple, it will give you highest probability. So the activation function will give you a set of probability. In our case there are four fruits, so we'll be having four sets of probability. So for the apple case, so second is the apple, we'll get maximum probability say 9.88, and we'll get minimum probabilities on other sets. So we can predict so we can calculate uh, this thing like by the probabilities mathematically. So I hope I'm clear with this is what is an activation function. If you still have question, you can ask me. So the question was actually what are the different uses of activation function. So there are many cases, many problem statement where you need to do some binary classification. Say it is a male or a female. This is a binary classification. In that type of situation, you majorly use sigmoidal activation function. And if you are working on bigger model, if you need probability of 10 different items, then you will be using something called a softmax function. So we'll see how it has been implemented and how we get the output in the coding session later in this session. So you'll get more clear with the activation functions and bias there. Till now, if I'm clear, please comment down below. And I was having a question. So weights are changed by machine itself, or we change it to get the outputs. So it automatically changed in the back and forth process, like I have explained, back forward propagation and backward propagation. Just what we get is we see how the error is getting decreased. Okay, so now we'll go further. If it is okay, then I'll go further. If you have understood what all the topic is till now, please comment something so I'll understand. It is cool, or I should again explain anything. Okay, so we'll go more detail in how forward propagation and backward propagation works. So as you can see, this is our neuron, the artificial neuron. We have two inputs, x1 and x2. These are the weights, as I have explained what the weights do and what activation function do. So in forward propagation, what we'll get is we'll get the summation. We'll get this where this is bias, and whatever output we get here, say we got a W3, then this is passed on to the activation function as described here, and we get the output. What output we get is we get the probability. As we know, probability is between 0 and 1. So we'll get the probability that how much the input data is likely to be the expected one. Suppose we have an apple and we are predicting is it an apple or not. So we'll get a probability of say very high probability greater than 0.8 from here. And if we are showing the machine chiku or other fruits, then it will show lesser probability, say 0.1 or say very low also. So this is what the activation function do. As I told, whenever we do a binary classification, we majorly use a sigmoidal function. So we are using here a sigmoidal function. So as I told, what we do in forward propagation, we pass we get our first output done, then we calculate the error. So this has been described in this slide. So I hope you are clear with the forward propagation, and then I'll move to is the backward propagation. What actually backward propagation do and how it has been done. So in this case, what our main objective in backward propagation is to change the weights associated with our inputs in order to get our desired output. Okay, so these are the mathematical formulas how we can achieve this. As we know, what are the components to go in backward propagation? We have the updated weight. At updated weight, we go in this manner. activation function. Sorry for my handwriting, but I'm really sorry. I'm first time using this pad for doing such things, so I'm not able to grab it perfectly. And here is the error. Okay, so what we need to do in order to reach up, in order to update with automatically is it what we'll be seeing in this slide. So this is called as chain rule. I hope in first year have seen this. Maybe you have gone through this. So how a derivative works. So consider S as summation, which is represented as this, and activation as sig model, as I explained it before. So whenever we use sig model, we are doing binary classification. Okay. So in order to update the W1, this is the formula, mathematical formula in order to do W1. So you can see here we have N and we have dE by d1 omega. So we need to find this and we need to pass on to this formula. So we'll get the new updated weight, and so this updated weight can be again applied to the forward propagation and we get the lesser error. So so this is how a formula works. So what we first do it, we derivate the summation, this thing, with respect to w1. If we want dew1, this is if we need to update first weight, we differentiate this full term, this whole term, with w1. This has been described here. And the next step is we differentiate sigmoidal function with ds. Okay, and like with the summation, and the whole neuron network or whole system has been derivated with the activation function. This is nothing but conjoint derivatives, which I hope you have learned in first year. If you have not learned and you need to understand this more, please comment down below. Or if you have understood how this works, we can move forward. Should I explain the formula in detail or it is clear? Please comment down in the comment section so I understand what to do next. Okay, so sorry, I forgot to introduce what is N. So N is called as learning rate. So I'll draw a graph over here, which will how we will see how the error should be decreased. So when we initialize weight at the initial stage, we get the highest error. Say our error is at maximum. Say here. Okay. Now, as we keep reducing our weights, it will reduce and go in this manner somehow. Okay, so this will be our graph for error with reduction in weights. Okay, so I'll plot this as this is error and with respect to weights. Okay, so in order to decrease this, with what speed should we decrease in order to get at this optimal position? It has been defined by learning rate. So if we have set a learning rate as twice, so it will reduce the time of reduction by twice. So it will take this step, like from here it will directly come to twice here, from here to here, from here to here. It is advised to have minimum learning rate, like we can put it to 0.1 or 1.1, something like this, in order to have in order to train your model in a perfect manner. So this is what a learning rate is, and we'll see how it is practically implemented and how it changes, how output changes depending on it. Okay. So I hope this is clear, how actually black propagation works in a mathematical manner. So I think we can move forward with different types of error, how we rectify error, or how we actually optimize it in a coding manner. Okay, so how it is implemented in a coding manner, I will explain. I'll start with that section now. So I'll start with what is a loss function. So suppose this situation, we have input 4 and 5, which is passed to this neural network as shown here. So this after going to this section, uh, the actual value should be 1, but what we got was 0.1. So what is the difference between them? There is a difference of 0.9 between the expected and what we actually got. So the function which actually measures the difference or measures the error is called as loss function. So this is what we'll be using in coding. So we have to declare the loss function, what type of loss function you'll be using. So there are various type of loss function, like there's various way to calculate loss. We can do directly subtract the actual from predicted one, or we can square them and then subscribe. There is various methods to calculate loss in mathematics. Then so we'll see this, and according to our example or our question, we can actually predict the way it should be, or which loss function should we use. Okay, so we'll move forward. So this is the first type, which is called as empirical loss. uh, so what we do, so as I have explained, this is for a single number of examples. So passing from, as we may have a number of examples, like let's say number of example is m. So m can be say 1000. Like if we are doing image recognition, say we are predicting a ball, it is a ball or not. So we have 1000 images of that ball, and they are labeled at the same time. So this is 1000 sets of example m. So loss function calculates the error for a single example at a time. So if say for first example our data is this 4 and 5. What is 4 and 5? They represent various parameters of the ball. So this is the first example of the 1000 example, and the loss calculated is called as loss function. So we need a quantity which completely measures the loss, like for our whole training set. Suppose we have 1000 examples in our training set, so we need a function which predicts all the loss at the same time. So this has been done by using empirical loss. It does nothing. So j represents as you can say here, j represent the empirical loss or the total loss for complete data set you have. It has been predicted in this way. Suppose our first example is 4 and 5. It is passed to this, and you get an output as seen before. It is 0.1, but your actual what you need was 1. So the difference between these two is 0.9. This has been stored in this empirical loss matrix. So a matrix has been created in such a way, like whenever you deal with the image recognition problem, they majorly works in matrices. So whatever data you get or whatever output you get, it is stored in a matrized form. So the first loss, empirical loss, will be like this. So from here we get 0.9. From the second data set we got say 0.8. From this we got some 0.4. This has been stored in matrices called as f of xi. So in order to get the average loss from this complete loss by what we got by a single losses, we use this formula. By using this, we get the total, what is the total loss of the system, like what is the total error generated by complete training examples. Like if we have 1,000 examples, so in average, what is the error generated by the 1,000 example is what we get through the empirical loss. So what will be our major objective is to reduce the weight, reduce the learning parameter in such a way, or to optimize the learning parameter in such a way that our total loss, like empirical loss, should decrease. We'll never deal with a single loss like for a single training set, but we'll deal with the complete training set. So that's why empirical loss is very important concept to understand, and this is the formula which has been used for empirical loss calculation. You can see I have calculated here. Similarly, it can be done if we are coding. We have to implement in this manner. I hope this is clear. If you are clear, please comment down below if it is clear. So I is nothing but the number of training example, 1 to n. So n is number of training examples. This is the question which is asked by which I got currently recently. So what this mean is, we'll calculate loss for each single example. Suppose my I is 1, so I'll get I x I 1 comma w y 1. So I'll calculate this and I'll get something like this. This is my first example, and I'll store it into my matrix which is represented by j omega j w. So in this way, we'll create a matrix for each and every training set which has been represented, which we have in our data set. CWN, sir, what do you mean by CWN? Like, I'm not understanding. Okay, so uh, I'll explain this again. What actually this is empirical loss mean. So we have seen what is loss function. Loss function is nothing but to predict error. To It predicts the error for a single training example. For a neural network, we have n number of training examples. Suppose we have 1,000 training example on which our system is to be trained. Okay, so loss function is nothing but which predicts the out what will be the error for a single training example. So this is the formula for calculating single loss for a single training example. Suppose my training example is number 1. So what will be my formula will be f x of I w slash y of a, this will be my formula. Similarly, for my next training example, say 2, I will replace I by 2. Similarly, for 3, I'll get 3 and I'll get the errors for them. So similarly, so empirical loss is nothing but the collection of all the singular losses. What I mean by singular losses for is the loss created by each single training example. I'll merge them all in a single matrix and I'll calculate the effective loss. And this is what we need to overcome, as we are training on a larger, we are training for whole data set, not for a single element. I hope I'm clear, and if yes, please comment down below. So I think it is clear now. Can you explain the equation again? Which equation do you want me to explain? Okay, so I'll move forward and I'll clear all your doubts and we'll see this in coding session. So these are various type of, as I told, there are various methods to calculate error loss. Like we can do it actual predicted minus actual, or we can square them and then we subtract them. There are various methods. So this is one method of them, which is mean square error loss. It is nothing, just we square them and we get the error. It is to avoid dealing with the lower probability. Like if you don't want to deal with values such as 0.1 or 0.2 something in terms of decimals, you can use this function. So it will make easier, it will make this learning easier, like it will be dealing in integer forms. Okay, so this is one of the method which we use for error calculation. And now we'll start with the coding session, like how we actually implement these things in coding. So this is the way we do it in Keras. So we just need to import this as as it is described, and it will work fine. Like I told before, like Python or Keras, it is an object oriented language. So what I mean by object oriented languages, we don't have freedom to define our own sequences. Like we cannot do this tf dot something on our own and we run the code. It is predefined and we have to use it as it is. What we can do is, we have, by object oriented, what it means is you have to orient your coding according to your object performance. So this is the syntax which we'll be using to introduce this type of error loss combination. So tf dot reduce min, this will do nothing. It will just do what the formula is, what this formula has been describing. It will subtract y and y predict and then square them, and it will be stored in matrix called loss. Matrix, what I mean by matrix, it is a set of elements. Like it will save all the losses for n number of training examples. I hope I'm clear till now. I'll move forward with this thing. Uh, okay, so the last part for the like theoretical session is what is optimizer. So we have seen this key, how to get the error, or how to predict what is the error is. Now we need to do back propagation. Like we completed with the forward propagation and we need to go back and update our parameters. So as we have seen, a lot of formula was involved in mathematical calculation. In coding we just do nothing. We just import a function called as optimizer. It does everything. So what is an optimizer? An optimizer is a concept which involves to update the in order to update the weights. If you call this optimizer, it automatically updates your weights depending on your errors. So there are various type of optimizer which can be used. So SGD, Adams, ADA delta, ADA grid, SRM prop. These are various type of algorithms, or the mm, what we say optimizer you can use. And if you want to learn it in detail, you can uh, visit the Keras documentation and you can understand how actually this optimizers work. But currently what we need is how to implement these things. To understand how this works, you can go on Keras documentation and you can actually learn how mathematically this system works. Currently, what my goal is to introduce you with the scenario of machine learning and how actually we implement it. Okay, so I hope it is clear till now, and so we'll start with our coding session now. If you have any question till now, please ask me. Do anyone have any questions regarding optimizers or any forward and backward propagation what we discussed before, please ask me. So if no, if yes, we can start with our coding session. Okay, I'll start with the coding section. I'll open the notebook. So s- I'll will start with coding now, and I'm sure I'll understand whatever I've been coding and whatever I taught you. But once we'll start coding, okay. So we'll start with building some basic models. So we'll start with what we called as hello world in machine learning. I hope I am clearly visible now because there are some issues currently in setup. Hope I am clearly audible. If yes, please comment down. I hope. So I'll start with the coding session now. So I have divided this in various modules, like how to start and how will go flowing. How should we actually design the system? So first of all, we'll start with importing various libraries. So first we'll import TensorFlow uh, as TF. You can use anything. You can even do this as TFS or whatever you want. This is the user defined section. So first is import TensorFlow as TF, as we'll be using TensorFlow as our primary premier library to interface various modules like optimizers, as I discussed, forward propagation modules or loss modules. Second, what I'm importing is NumPy as NP. This is majorly used when we deal with the numeric data, like to predict numeric values, or if you are given the house, if you're building a model to predict your house rent or how much area wise a house may cost you. It is all related to numbers. So whenever you deal with numbers, you should work with NumPy. It is the best library which is currently available. And the third library which we will be saying is Keras, which is a subpart or API of TensorFlow. So I hope the libraries are clear. How I hope the libraries are clear. So next step is defining your model. So first, in this case, we have defined our input and output. So this is a hello world. So we manually define what is our input and output. So as our input has been defined as 1 2 3 4. So what we are building here is we are predicting uh, the house of a rent depending on how much bedroom it has. Suppose it has one bedroom, so the rate for that will be one, like 1 into 1,000, like it will be 1 lakh rupees. So we are not able to deal with a larger number, so I'm using this converted value. So if we are using 1 in output, which means 1 lakh, and if I'm using 1.5, which means 1.5 lakh rupees, or 2, it is 2.5 lakhs, or 2.5 is 2.5 lakhs, 3 is 3 lakhs, or 3.5 lakhs as described. So when we have a one bedroom flat, it will cost you 1 lakh rupees. Two bedroom, it will cost 1.5 lakh rupees. In this order, we have defined our data and we have labeled its output. Okay. So now what we'll do, we'll first of all we'll declare a model. So by declaring model, what I mean is uh, how many layers it should be, or how dense it should be. So currently we'll be building a single layer module. like it has only one perceptron, as our data is very less, so it is very easier for the model to predict a single layer network. So if we have bigger data, as we have seen, if we have bigger data, we need a complicated or congested models. So this is very small data, as it is a hello world problem, so there is no need of using a dense model. So this is the method which we use in Keras to define the model. As we have seen, it is very complicated in mathematical way to represent, but this is just one line of code. What you need to do. So what I did in this code is I have uh, declare a sequential model. By sequential, what I mean is my all the layers are in sequence manner. If I'm using 3-layer network, it is in sequence, like first layer, second layer, third layer. Whenever you define a model in Keras, you should do in this way. It should be tf.keras.sequential. Then what I do is I define how many units are there in my model. So as I told, it is a single unit model. So I'll describe it as unit equals to 1. What I mean by unit is how many layers it has. Okay. So I have only one layer. So and what is the shape of that layer? It has one input and one output, right? If we are providing one value as input and we are getting one value as output. So input shape will be 1. So this is the way you declare a model, and this is the first step what you do while you start coding. So the next step is we'll compile the model. So we have done the forward propagation. Now what we need to do is backward propagation. What was in the, what we did in forward propagation was we used to do we used to force the model to run and get some values, so that we can predict, we can change the learning parameter and get the desired output. So the next step is we'll do backward propagation. This is the, I'll comment it out, propagation, and the second one is the backward propagation. So what are the major parameters you need to specify in backward propagation? So backward propagation, what we compile the model. So we'll do this model dot compile, and we specify two things: how our loss has been calculated and what type of optimizer we are going to use. So as I had shown you, there are various type of loss you can use, or various type of optimizer which you can use. So I am using mean squared error loss type, and optimizer as SGD, which means standard gradient descent. You can learn about this standard gradient descent. You can just search on Google and what is standard gradient descent. You will understand what is standard gradient descent. So I'm using this optimizer, which is standard gradient descent and mean squared error, to calculate my back propagation. Once I'm done with my back propagation, what I need to do is I need to fit the model. Like I need to give data to the model. So I'm in the third state. I will give data to the model, providing data to the model. So here, if you see, model.fit is used to provide the data to the model. So here you can see there are majorly three parameters which you need to specify. X is the input, what are the labels for it, and Apache. What we mean by Apache is, if we set Apache to 500, it will go through the data set, like it's a single data 500 times, means a single data will run through the model to 500 times. Why we do this? To it is majorly done to avoid any types of error due to misfitting of data. Suppose there are many cases, this never this is never encountered in case of data, like numeric data, but it majorly seen in case of images, like the image is not stable, or it is vanishing, or it is distorted. So by passing the same image through a same model repetitive times, the chances of reducing that error reduces. As a result, specifying Apache is an important parameter. So I am specifying Apache to 500, and then what we do is we call model.predict function, and the which will predict our output. Okay, so I'll say I'll train this model. I'll run the code. So I'll pass a date. argument say 7, I have a if I want a 7 bedroom flat, so what should be the price of that house is what I want to predict. So when I will run this code, I need to remove this thing first. I will run this code. It will take a bit of time, like we are using uh, almost 50% of my computation power to support the live session, so it will take some time. So as you can see, my apologies is running. This is the first one is for my first example. So you can see my all example has been going through that apology 500 times. So here you can see my loss is computing. At the first apology, my loss was around 7.6948, and it is decreasing constantly. Which what it means is my weights are getting updated automatically. Okay. So at the end of 500, what we'll see is the updated loss, and this is the minimum loss which can be achieved. See, as you can see, it is running 500 times. So the answer for my prediction is 4. For what I mean is it is 4 lakh rupees. If I want to buy a 7 bedroom flat, it will cost me 4 lakh rupees. Now we'll check it how it is perfect or not. For one, it is 1 lakh rupees. For 2 bedroom, it is 1.5 lakh rupees. For six, it is 3.5. For seven, it will be 4, obviously. So our prediction is near to close, near to expected value. So this is how a model works. So if I hope I have explained the code properly. So if you have any doubt regarding code, please ask me in the comment section. So do you have any doubt regarding this coding session? Should I explain it again, or you are not getting any points, you can ask me. Okay, so there is a question ki how model.compile or model.feed actually works. So the statement before Apache is access and bias. So access is my input and my desired output for them. Okay. So what I mean is we'll supply input and output for a training set. So this is my training data. Okay. So I'll supply my input like what in this case what it is represented as xs or ys is my output, what we call as label data. So in model.feed, what we majorly do is we supply training data and label data in order to run the model. So it is, I hope the question is clear. Okay, so this was the hello world explanation how a basic model works. So I think it is already 2 hours, and it was a 1 hour session, but I stretched it to 2 hours and many people. So what I think is I'll end the session today at this stage, and I'll upload a video for my next. I will upload around 2 videos which will be based on more complex coding sessions. So to increase your knowledge regarding all the optimizers and everything, I'll suggest you to go through all the optimizers theory and the documentation, so we can connect with it in later sessions. I hope it is clear, and if it is okay, then give me okay or something so I can understand. Okay, I have some questions, so I'll answer them. To what value the apology works? I mean the extent. It can be anything. So we'll run it for 1000. Let's say. What happens if we change the apology to 1000? So there is a limit. Like after certain limit, the loss will not decrease as much. Like we cannot build a system which is 100% accurate, but our main objective is to reach as close as we can. Okay, so there is a question, where do we apply activation function in the code? So in this code, as it is single layer, so activation function is majorly automatically chosen, which is the sigmoidal function. Okay, so in order to apply a activation function, your network should be a bigger network, not a single layered network. This is a hello world example, so therefore I'm not be using activation function here. There is another example which I have been shared, whose link, the link has been shared on GitHub. I shared my GitHub link. You can go through that example, and if you have any doubt in that example, we can discuss it. So as this session has been extended for 2 hours now, so it is not possible for me to take that part today itself. So if possible, we can connect tomorrow or day after tomorrow and I explain how the second program works. Is it okay? If okay, then please comment something so I'll understand I should end this session now, or okay, cool. I'll end the session today at this point, and I have shared all the coding links with description. Like I've written a blog on the code, so you can go through that blog. And if you have any doubts, you can comments anything on that on GitHub itself, or you can message me privately, or you can call me anytime. I'll answer each and every question which we have, and